So welcome back, guys. Today again we'll discuss what is a new concept called symmetry. So what is that new concept called symmetry? So why you called a parameter like a circuit? So we need to prove a circuit whether it is symmetry or not. So for example, this is a two networks which is represented a different way. So for example, this is a T network. This is the box I am keeping. Don't get confused. This is one port and this is another port. Okay. Now my job is to know whether this two-port network is symmetry or not. I am replacing the same network. I am keeping this network as M and I am giving the same things. So I am replacing these two networks in different way to show that the given circuit is symmetry or not. To know what is symmetry means, the input impedance, the input impedance of one port should be equal to the impedance of other port when the port should of other port should consisting of open circuit, should have open circuit. So the input impedance or impedance, that is not impedance, the input impedance of one port, that is impedance of this port, should be equal to impedance of other port when the impedance of this port, if other port is open circuited, and the impedance of this port when this port is open circuited, you will get symmetry. If that door impedance are equal, you will get symmetry. That means the symmetry means, so again, welcome back, guys. Today we will discuss what is the symmetry. It's a new topic in two-port networks. So what is the symmetry means? In general, for example, if you take for symmetry, I take this input impedance port as V1 and the current as I1. And for this output V2, and I am naming as this is I2. You all know this. So V1 current is entering I1. For this V2 current entering is I2. So what is the symmetry means? The input impedance, let us say that is V1 by I1, input impedance should be equal to output impedance. If you show this in any network, it is called, it is said to be, it is called symmetry. It is called symmetry. So that means the input impedance and input impedance it should be equal to output impedance. Then it is called symmetry for any network. So for example, if a network I am taking here is, I am representing, for example, this is the network I have. This is the two-port network I have. Okay. I name this as network N. The same network I represented here and here. To show the symmetry, I need to take the response from input. Okay, that is V1 and I1 I take response. To get the response of input impedance response, To take input impedance response, I make I2 current as 0 at this condition. Let us assume that we are conducting an experiment. If I make I2 current is 0, I will get input impedance. Okay. If I make I1 current here 0, you will get output impedance. So here, in this case, while conducting experiment, we get V1 I1 one equation and V2 I1 in other equation, V2 I2 in another equation. We equate both that and we get the symmetry condition of any parameter. Let us take we have a Z parameter. In Z parameter, for conducting experiment, both output sources and input sources should be equal. So we assume V1 equal to Vs and we assume we have output current is 0. Again here V2 equal to what? Vs we take and I1 equal to 0. These are two assumptions to conduct the experiment. Finally, we need to reach a value of Vs by I1. Since we named this as V1 and again Vs by I2. This is also equal to V1 and this is equal to V2. So for Z parameter, let us for this circuit, I am having a Z parameters as V1 equal to Z11 I1 plus Z12 I2 and again V2 equal to Z21 I1 plus Z22 I2. Okay. Substitute these assumptions for this experiment circuit. What do you get? Let us say this is equation 1 and equation 2. Substituting equation from equation 1 V1 equal to Vs, from 1 we have V1 equal to Z11 I1 plus Z12 I2 equal to 0 and again from 2 you have V2 equal to Z21 I1 plus Z22 0. So V1 is represented should be Vs. So what we required is Vs by I1. So if in this circuit we see carefully, by this circuit, that is by equation 3, from P we have Vs by I1 equal to Z11. So this is the condition we got, that is to make this port, this input impedance V1 by I1, that is we got Vs by I1 equal to Z11. Now okay. From this for this circuit, and again I am replacing the port. I keep it the source V2 equal to Vs here. Now we will see the fate of the circuit. For example, I am taking again the port networks, that is Z11 I1 plus Z12 I2 and again V2 equal to Z21 I1 plus Z22 I2. Substitute these two things here. Substitute the assumptions. By substituting in equation, let us say this equation as 4. Let us say substituting the equation in 1 and 2. So from this is 4. Let us take this is 5. From 4, what do you get? So V1 equal to Z11. In case of I1, you place 0 plus Z12. In case of I2, we keep that I2. And again, from 5, we have V2 equal to Z21. In place of I1, you get 0 plus Z22 equal to I2. So by observing this equation, that is equation, let us say this is 6. Let us say this is 6 and this is 7. From 7 you have V2 by I2. So in place of I2, we replace V2 as Vs. So we from Vs equal to what we got? Z22. So input impedance Vs by I1, output impedance Vs by I2 equal to 2. So as for our requirement, substitute this and this here. You get in place of Vs by I1 you get Z11. In place of Vs by I2 you get Z22. So this is the symmetry condition for Z parameter. The circuit, if you given a circuit, let us take that is T circuit. So you will find the Z parameters of that circuit. If you get Z11 equal to Z22, then you will decide that this circuit is a symmetric circuit. That is, the condition is your required meeting is Z11 equal to Z22. If you make Z11 equal to Z22 for given circuit, then you can simply say that the circuit is a symmetric condition. Okay, then now we'll find the condition for Y parameters. So the next story is the same. So you'll have the conditions. You replace that equations in there. So the condition we are taking is V1 equal to Vs and I2 equal to 0. So many will get doubt. Sir, if you make I2 equal to 0, what about the V2? So if making I2 equal to 0 not affecting the voltage across the output terminals. So by this time you will get about what is the open circuit and what is the short circuit. Knowing that open circuit and short circuit, you can go through this two-port network. So if you make V2 means there is no way to nullify the V2 value. Okay, there is not indifferent. So I am taking these assumptions, and for this also we have assumptions. And now the Y parameters in general you have by default the values of I1 equal to Y11 V1 plus Y12 V2 and I2 equal to Y21 V1 plus Y22 V2. Okay, this is the so according to assumptions, this is equation 1, this is equation 2, let us say. Okay, substitute our assumptions in 1 and 2. So from 1 you get, so I1 is not affected, Y11, in place of V1 you substitute Vs plus in Y12. In place of V2, what do you do? So V2 is there, so we keep V2 there. From 2, you have I2, in place of I2, we are making I2 is 0, make 0, and Y21, what is about Y21? Y21 is replaced there, and if we base Vs, replace, and Y22, V2 also we replace. Now, actual thing is start here. We want equation in form of Vs by I1. Our agenda is to get the equation Vs by I1. Examine these equations. From this equation, if you want Vs by I1, you have V2 as an obstacle. In this equation, V2, Vs are there, but is no chance of I1, but Vs, V1. From this equation, let us say, I am naming this as a 3 and this is as 4. By 4, we can transform this V2 in the form of Vs, right? So from 4, this can be further reduced into V2 equal to how? So minus Y21 Vs by Y22. Okay? Substitute this equation here in equation 3. So from substitute V2 in 3, you get I1 equal to Y1 Vs plus Y12. So what is the V2 we got? Minus Y21 by Y22 Vs. So make Vs as common here. Where Vs as common. So I1 equal to Vs common. So Y11 Y22 minus Y12 Y21 by Y22. Okay. Therefore, Vs by I1 we obtained Vs by I1 as Vs by I1 as Y22 by Y11 Y22 minus Y12 Y22. That is Y22 by delta Y. So Vs by I1 equal to, you got Y22 by delta Y. Okay. So this is experiment 1. Now we will go to experiment 2. That is assumptions replaced in equation 1 and 2. Assumptions giving to 1 and 2 equations. So you will get I1 equal to, substitute this, I1 is 0, you are making it 0, equal to Y11, in place of V1 is V1 plus Y12, so V2 is replaced by Vs, and again I2, so V2 is replaced with Vs, and again I2 is replaced similar way, don't change that, and Y21, in place of V1, we keep that V1 plus Y22 equal to Vs, V2, that is Vs. So we require again what? Vs by I1. From this circuit, if you can V1, so from this is equation 5 and equation 6. From 5, you have V1 equal to minus Y21 by Y11 into Vs. Substitute V1 in 6. Substitute V5 in 6. You will get I2 equal to Y21 by Y1 Vs plus Y22 Vs. So therefore again we make Vs common. And you will get here minus. So Vs equal to Y21 Y12 Y12 minus Y11 plus Y22. So further transformation, you will get this as Vs by I2 equal to Y11 by Y delta. So Vs by I2 equal to what? We got Y11 by Y delta. So transforming this equal to Y11 by Y delta. So equating the input impedance and output impedance. So you cancel this both things. So finally you obtain Y1 equal to Y22. So this is a symmetry condition of Y parameter. So what I did simply, I just have the assumptions here. I kept these assumptions in our Y parameter network, and keeping in mind that input impedance Vs by I1, I just extracted that Vs by I1. Here I got Y22 by Y delta, and again I replaced the source V1 with to other port, that is keeping V2 equal to Vs, and I made input port equal to 0. And again assumptions I kept in the circuit, and after that keeping in condition of getting Vs by I2, got Vs by I2 as Y11 by Y delta. So equating Vs by I2 and equating Vs by I1, you got this equation, that is symmetry condition of Y parameter. So similar, the same story continues. If you are giving a circuit, you will find all Y parameters. If you get Y11 equal to Y1, Y22, then you decide the fate of the circuit. It is a symmetry. It is symmetry. That's it. Now we will go to other parameters, that is H parameter. Now for it get to H parameter, for this H parameter, all things so what are the H parameters we have? V1 equal to H11 I1 plus H12 I2 H12 V2 H21 I1 plus H22 V2. So this is H parameters you have. Okay. I'm naming this as equation 1 and equation 2. So substitute assumptions. V1 equal to Vs and I2 equal to 0 in equation 1 and 2. From 1 you will get V1 as Vs equal to H11, I1 as what is I1? I1 is you kept like that only. So H12 in place of V2 it is also replaced by same only. And again from 2 you have I2 as 0 and H21 I1 plus H22 V2. So our thing is to get Vs by I1. So Vs means this Vs by I1. We need Vs by I1. But in this circuit, we are having this is V2 is abstracted. From this equation, let us say this is 3 and this is 4. From 4, you have V2 equal to minus H21 I1 by H22. Okay. So replace this equation, substitute this V2 in equation 3. Substitute V2 in 3. You will get Vs equal to H11 I1 plus H12. V2 means minus H21 I1 plus H22. Further calculation, you will be obtained Vs by I1 as, so Vs by I1 as, I am replacing this as H11 H22 minus H21 H12 by H22. Okay, this is the equation we got from this, that is Vs by I1 H11 H22 minus H12 H21 by H22. Okay, so I am replacing this thing here. So in place of V1 by I2, I got this thing. Now what is about this thing? Substitute same V2 I1 in equation 1 and 2. That is V2 equal to Vs and I1 equal to 0 in these equations. So you will get from equation 1 V1 is replaced and H11 I1 is 0 plus H12 V2 is Vs and I2 replaces like that only, and H21 in place of V1 I1 equal to 0 and H22 equal to Vs. So we need what? Vs by I2. So Vs by, from this equation directly you get Vs by I2 equal to 1 by H22. Okay, so Vs by I1 you got this thing, and Vs by I2 that is equal to, you need to replace this thing, that H22 1 by H22. So further we will get this calculated and we will get whole thing, that is H11 H22 minus H21 and H12 equal to 1. So this is the condition, symmetry condition for H parameter, that is delta H equal to 0. This thing, entire thing can be replaced as delta H. So this is the symmetry condition for H parameters. Okay. So again the same story runs here also. So V1, the main thing for symmetry you should keep in mind is, again we need to find input impedance, that is V1 by I1. So V1 in place in the Vs, that is V1 by Is. Why I kept Vs means same voltage I am keeping, but we are doing experiment in general. So Vs by I1. So I separate this in this for one circuit. I calculated this. If you do in experiment in your lab, for example, if I give a circuit for you, so if you want to find it in lab only, we will find all these things. One time you will keep this circuit, you will make output port as 0, that is open circuit, and you will do this, we will get input impedance. That input impedance you got in this form, and other circuit will drop, and you will find that you will got that one. So equating that is, and you will get the condition for H parameter. So this is the condition for H parameter. Now we will switch to ABCD parameters. Okay. So what are the ABCD parameters you have? So V1 equal to A V2 plus D minus I2. And again we have I1 equal to this is B, I think, yeah. C V2 plus D minus I2. Okay, I'm naming this as equation 1 and equation 2. Substitute V1 equal to Vs and I2 equal to 0 in equation 1 and 2. So from equation 1, you will get, so V1 as Vs into A. So V2 means again, there is no change here because no impact of this input impedance finding, plus B into I2 means we will have impact, that is minus 0, so minus of 0. And from 2, substituting these assumptions in this, you will get I1 has no impact and C V2 plus D minus 0. Now our thing is we have to find Vs by I1. See, if you see Vs by I1, anything, we have the lead. So yes, Vs by I1. So the lead we are not having here, I think. So V2 means again Vs by I1. We need Vs by I1. So that means so from this equation we get V2 equal to I1 by C. Substitute this V2 here in equation. Let us say this is 3, this is 4. Substitute V2 in 3. In equation 3, you will get Vs equal to A into I1 by C. By this you will get Vs by I1 equal to A by C. So this is output response. So one second, let us check that V1 equal to A V2 plus V minus I2 and I1 equal to is okay. So we replace V1 in place of V1 I kept Vs is okay, V2 and V0, and again I1 equal to C0. So everything is okay. Now I need Vs by I1, that is Vs by I1 I need. So okay, directly we will get this, I hope. No. So now Vs by I1. So Vs, so from this equation, if you replace V2 equal to, you will get I1 by C. We will replace this equation in this, and you will got Vs by I1 form. Therefore, A by C. That's a fine. Okay. Now go to this circuit. So substitute this V2 equal to Vs and I1 equal to 0 in these things. You will get from 1. V1 equal to, so V2 means Vs plus V into minus I2, and from 2 you have I1 equal to 0 equal to C into Vs plus D into minus I2. Okay. Now we need Vs by I2. So directly we are having this Vs by I2 here. So CVS equal to dI2. So for Vs by I2, you get D by C. Okay. So you got V1 by I1, V1 by I1 as A by C equal to V2 by Vs by I2 as D by C. So you cancel C, you will get A equal to D. So A equal to D is a symmetric condition of ABCD parameters. So the same story runs here. Again we are taking assumptions, we are substituting the equation and we are getting Vs by I1 as A by C and Vs by I2 as D by C. You will equating these two things and you are getting A equal to D. So to doing all these things, what I am assuming initially is, I need to find out input impedance and I am doing output current as 0. And then to find the output impedance, we are making I1 as a similar condition and replacing this and substituting that. Okay? This is about the symmetry condition. In the same fashion, we have a reciprocity condition also. We will see that later. Thank you.